Welcome folks. In this video we are going to look at how to write the chemical formula of ionic compound. Now if we are to give a simple definition of an ionic compound, this is a compound which is made up of the first one, a metal and a non-metal, and during the chemical bonding, a metal tends to lose electron or electrons, while a non-metal tends to gain electron or electrons to become stable. Now for us to make this principle of chemical formulae simple, we need to have the valences of elements on the periodic table and also for the atomic compounds. Now first we begin with group 1 elements. Now, I'm not going to list every element that is found under group 1, so I'll be just taking some of at least 3 of the elements from each group. So, we'll begin with group 1. So, for group 1, I will take lithium, sodium, then potassium. So, all these, including the others, have the valence of 1. Then for group 2, we have beryllium, we have magnesium, calcium, so valence 2. Group 3, we have boron, aluminium, gallium with a valence of 3. Group 4, we have carbon, silicon, germanium with the valence of 4. So what you can just master here is that from group 1 up to group 4 on the periodic table, each group represents the valence assigned to that group. Then what happens if we start from group 5 up to group 8? So let's now continue. So here we have group 5. So for group 5, we need to subtract the group from 8. So 8 minus 5 is 3. So for group 5, we have elements such as nitrogen, phosphorus, arsenic. All these have the valence of 3. Group 6, same pattern, it's 8 minus 6, giving us 2. Under group 6, we have oxygen, sulfur, and selenium. So the valence of 2. Then for group 7, it's 8 minus 7. So for group 7, we have the valence of 1, and we have elements such as fluorine, then chlorine and bromine with the valence of 1. Then for group 8, we know that the group 8 have the valence of 0. It's 8 minus 8, which is 0. That's why you consider this as the electrically stable. Now, if you look at the similarity, group 1 have the similar valence to group 7. So we have the similar valence of 1, then 2 with group 6, 3 with group 5. Now let's look at the first example. So the first example, we are going to write the chemical formula of sodium chloride. So on the ionic compound, whenever you see IDE, this simply means it's a non-metal. So the first part represents the metal, then the second part represents a non-metal. And for the symbol for sodium is Na, then with a valence of 1. Chloride from chlorine is in group 7 with a valence of 1. So we can see that they have the same number. So whenever they have the same number, the chemical formula just remains like this. You don't write the subscripts. Okay, let's have the second example. So the second example, let's say we use potassium iodide. Now IDE, it's a non-metal. Iodide, which is iodine, comes from group 7. Potassium has the symbol of K with a valence of 1. Iodine has a valence of 1. So we can see we have even numbers. So it's still Ki. The third one, right? Let's say we take an element from group 2 and from group 7, the non-metal. So calcium has a symbol of Ca with a valence of 2. Chlorine has Cl with a valence of 1. So on this one, we are going to swap the valences. We are going to use this method called the crisscross method, where the one from the chlorine becomes the subscript of calcium, 2 becomes the subscript of chloride, which is our final answer will be calcium chloride with the subscript of 2 here. Now it's very important you write the correct chemical formula, especially when you're dealing with the balancing of chemical equation, because sometimes if you just miss out on writing the correct chemical formula of a compound, that may give you issues on how to balance a given chemical equation. Now before we proceed, let's look at this one visually. So if we are to draw the outermost shell of sodium, sodium has 1 electron in its outermost shell. Then for chlorine, we have 7 electrons. So the chlorine needs 1 electron to become stable. Then for this one, has to donate 1. So if the number of electrons given equals to the number of electrons acquired by a non-metal, if those two are equal, then they form 1 to 1. For this one, it's a 1 to 1. For this one, it's a 1 to 1. But for this one, it's a 1 to 2, which means that for calcium to be stable, it needs to give out 2 electrons. But 1 atom of chlorine can only receive only 1 electron. So if this 1 electron goes on this part, we need another atom of chlorine to get the other electron. Thus we have these 2 here. So that's what it simply means. And if you want more of this, you can just search on my channel. I have a video for ionic compounds where I've explained these in details. Right, so now let's move on. Now let's say we write the chemical formula of lithium oxide. Right, so lithium is Li with a valence of 1, then oxygen with a valence of 2. So for this one, we know that our chemical formula will be L2 then O, which means that 1 atom of oxygen needs 2 more electrons to become stable, but 1 atom of lithium can only donate 1. So in total, we need 2 atoms of lithium to donate 2 electrons that will satisfy 1 atom of oxygen. Right, now we move on. Let's say we want to write aluminium chloride. For aluminium chloride, the chemical formula for the first part, aluminium, is Al. Then this has the valence of 3. Chloride has a valence of 1. So if we swap the numbers, this will give us Al Cl with a subscript of 3. 1 atom of aluminium needs 3 atoms of chlorines. Right, then let's say now we bring in maybe some polyatomic ions. So let's say we want to write calcium sulfate. Now for polyatomic ions, I have also a video, and this you can just search for that one. Then you need to look at these ions, then also the valences associated with each ion. So they are very important. Now for calcium, calcium has the chemical symbol of Ca with a valence of 2. Then sulfate is SO4 with a valence of 2. So what happens if you have numbers greater than 2 but equal to each other? So what you just have to do here, you just have to cancel this. So the chemical formula for calcium sulfate is this one. Right, we move on to, let's say we take calcium with the hydroxide. Now let's look at where the valences are different. For calcium, it's valence 2. Then for hydroxide, which is OH, this is also a polyatomic ion, has a valence of 1. So whenever a number greater than 1, like 2 and above, is swapping with the valence of a polyatomic ion, then the polyatomic ion, which is our OH, must be enclosed in brackets. So this is what you do now. So whenever you see a number outside the subscript, outside the bracket, it means that whatever that is inside here is a radical or a polyatomic ion. But never write, like if you look at this one, calcium chloride was written like this. We didn't put the calcium in bracket since the calcium is just, the chlorine is just an individual element. So whenever you are dealing with a metal with individual element, you don't have to consider the brackets. But if you have a metal and a radical, then the brackets must come in. Right, let's say we want to now look at, let's say, sodium sulfate. So for sodium sulfate, sodium has a chemical formula Na with a valence of 1. Sulfate has this with a valence of 2. So the 2 will go on this number, 1 will go on this number. So if you look at the difference between this and this is that the metal on sodium sulfate has a valence of 1. So the subscript here is 2. Since it has a valence of 1, the sulfate, which is the ion, polyatomic ion, will not be enclosed in brackets. You only put this in brackets if the valence is above 1. So you need to put that into consideration. Right, we move on. Let's say we want to look at a chemical formula for, let's say, sodium phosphate. So sodium has Na, valence of 1, phosphate is PO4 with a valence of 3. So even this one will just give us Na3 PO4. What of ammonium chloride? So ammonium has the chemical formula of NH4. NH3 is ammonia, so that's a difference. So ammonium, NH4 has a valence of 1, then the chloride has a valence of 1. So if we swap these numbers, the chemical formula will just be NH4Cl. Right, so this is how you can write the chemical formula of ionic compound. So you just have to get the concept, because there are other compounds that we've not mentioned in this video. So the concept is you need to master the valences of each element on the periodic table. Then for polyatomic ions, these just have to be committed to memory. You can search for a video with these parts here. So that's it for this video. Thanks for watching.